Excavate the chamber system bed to the dimensions shown on the chamber system drawings. A flat, level, and firm subgrade is needed to support the chamber system. Once the bed is excavated, a geotechnical check should be conducted to verify the subgrade bearing capacity of the native soil. Cases where the subgrade bearing capacity is insufficient for the design chamber load will be addressed at this time. Table 1 of the chamber system drawings should then be used to confirm the stone foundation thickness. When the subgrade is too soft, there are methods that could be used to improve the bearing characteristics of the native material. Once the stone foundation thickness is confirmed and the subgrade is at the proper elevation, a 6-ounce non-woven geotextile is used to cover the bottom and sides of the excavation to form a barrier between the native soils and the chamber system storage envelope. A 6-ounce non-woven geotextile is used to cover the bottom and sides of the excavation to form a barrier between the native soils and the chamber system storage envelope. The geotextile should be rolled in the direction of the chamber rows while maintaining a 24-inch overlap with adjacent layers. Note number 4 on the cross-section detail identifies the minimum foundation stone thickness that is increased as necessary per Table 1. Once the foundation stone thickness has been confirmed, a clear crushed angular stone is placed and compacted to form a flat, level, hard surface for the chambers. A vibratory compactor typically provides the best results for a flat, level, compacted foundation. Compaction requirements are typically met using 2 full coverages with a vibratory compactor. Placement begins at one end of the chamber system. It advances equally in the rows toward the opposite end while maintaining the chamber spacing dimensions shown on the chamber cross-section drawing. There may be a manifold at one or both ends. In any case, begin with manifold assembly by positioning the first chamber and end cap of each row with the respective manifold stub. Manifold stubs are inserted into select rows as shown on the chamber system drawings. Cutout templates for the various stub diameters are provided on each end cap, along with a starter hole for a reciprocating saw to help ensure a close fit. Stubs are inserted into the chamber row 1 foot from the end cap, except for the SK0290, which is inserted 2 feet. Non-woven geotextile, i.e. filter fabric, is used to wrap the stub at the end cap to prevent stone from infiltrating the chamber row through the gap around the connection. End caps overlap the first chamber corrugation, and each subsequent chamber overlaps the last corrugation of the previous chamber. An arrow is provided on each chamber to identify the direction of placement. Chamber systems may also include the sediment strip, an entire row that is completely underlain by a double layer of woven geotextile to accommodate water jetting operations. Embedment stone specifications are identified on note number 5 of the cross-chamber section drawing. Before initiating the chamber embedment process, ensure scour protection is in place and inspection port locations have been identified with installation preparations in place before chamber embedment progresses too far. An initial stone weighting of the chambers will help secure the chambers while the embedment begins. Carefully dumping stone directly on top of the chambers will keep them weighted as stone slides down each side to form an anchor. Embedment is achieved using a stone conveyor shooter system that can be stationed off the chamber bed during the entire embedment operation. Excavators may also be used, but will likely need to be stationed on the chamber bed in front of the row assembly process in order to maintain adequate reach for dumping the stone. Embedment must be done evenly across all rows in order to prevent unbalanced chamber loadings. This is typically regulated by limiting the differential stone elevations across the rows to 12 inches. Clean crushed angular open graded stone used for chamber embedment is typically regarded as compacted when allowed to fall in place from the height of at least 18 inches, and therefore no mechanical compaction methods are needed during the chamber embedment phase. The chamber embedment operation is complete when the embedment stone reaches the elevation of the chambers shown on the chamber cross-section drawing, at which point a non-woven geotextile is placed over the embedment stone to complete the geotextile envelope around the entire chamber system. The geotextile is rolled into place while maintaining a 24-inch overlap with adjacent layers. Backfilling above the storage envelope may involve a range of backfill materials, placement methods, and grading equipment. See notes 6 and 7 of the chamber cross-section drawing. Initially, small lightweight track equipment may be used to raise the grade, provided that material is pushed parallel to the chamber rows at all times. Table 2 of the StormKeeper installation guide lists the maximum allowable wheel, track, and roller loads that correspond to dumped or compacted fill heights above the chambers. Vibratory rollers may be used to meet compaction requirements in accordance with Table 2. It is critical to observe that a minimum of 6 inches of compacted fill above the storage envelope is needed to meet the minimum cover requirement for the maximum allowable roller load at that elevation. The minimum cover requirement for the chamber system is designed to support a paving operation, and therefore a portion of this minimum cover would include the pavement subbase constructed to roadway standards.